Thank you. Back again. Right, good afternoon, everyone. I'm James. Many of you know me. And
I'm Alex. Many familiar faces from last year. Now, one little bit of feedback we got from you last year is that we covered a few topics in no detail whatsoever. So this year, we're going the other way. We're going to drill right down into the details. So following this presentation, which is an overview, we'll be running 3 breakout sessions in room 1, 3 in a row right after this.
yeah, so a lot of you would have got a bit of a shock last year, I suppose, when we said P2 plugins has reached maturity and we're not doing any more on P2 plugins, and that framework is as advanced as it's going to get. And although that's true, we're not really doing any more feature enhancement in our P2 plugin framework. We have been looking at the tooling, and we're trying to get the tooling to work a little bit better. Unfortunately, or fortunately, I'm not sure what, that's not been in AMPs. So we've got a lot of extra tooling now, which is not in AMPs, but we haven't forgotten about AMPs. We will sort of revisit AMPs and make it work again at some point. So today we're going to be talking about 3 things chiefly. We're going to talk about how the plugins in the OSGI framework ties together. We're going to talk about, or we're going to try and encourage you to do build-time transformation rather than runtime transformation.
Not mandatory, but makes your life easier.
And we're going to talk about Quick Reload, which is our replacement for Fastdev. Brad Baker wrote it. I don't know if Brad's in the room. And we're going to look at some of the diagnostics tools that we've developed during some of our Innovation Week sprints.
Diagnostics, it really should read new toys, but Grumpy Bum over there wouldn't let me put that on the slide.
Okay, so I'll let Alex talk to you about OSGI because he loves OSGI.
I'm partial to OSGI. So in order to interact with the Atlassian plugin system or to create a P2 plugin, you need to be aware that you are using OSGI. Now, the plugin system attempts to hide a lot of that and attempts to let you think that you're not running in an OSGI context.
Well, we'll do a quick little survey here. We'll see if that's true. So I'm presuming you're all plugin developers here. How many of you have never had to touch the import section or the export section of the manifest? Yeah, that's what I thought.
What? I saw a hand over there. Yeah. So, yeah, law of leaky abstractions. It hides most of it, but not all of it. So, a plugin is an OSGI bundle with a little bit of extra sauce. It doesn't mean that an OSGI bundle is a plugin. So you can't just drop in a regular OSGI bundle and expect it to behave as a plugin. You need to do a little enhancement, which I'll get to later. Now, when I say drop it in what? So our Java applications are Tomcat web applications with a web application class loader. And so into that, we've put the Apache Felix OSGI container. And that's what we throw all the plugins into.
And of course, the real reason we use OSGI is to give us class loader isolation. Okay, we want the illusion that your bundle is operating in its own class loader and won't be broken by some other bundle coming in and misbehaving. Of course, it's a little bit of an illusion because Java doesn't really support a great modular story. So I've already mentioned imports and exports. Imports and exports are the real key to OSGI success. Simply, you sort of say, everything that I want to make visible from my bundle goes into an export section. everything that you want to see from other bundles, or indeed from the host application, you put in an import section, and OSGI magic makes sure that we have, that those classes can be visible at runtime, okay? And it's that magic that often goes wrong, okay? And we are trying to fix that by giving you the Spring Scanner, but it's important that even with tools like the Spring Scanner and all the rest of it, you have to know what's in your import and export section. You can't just shove import star optional and cross your fingers, because it will break.
And it won't break at build time, it'll break insidiously at runtime. Now, speaking of exports, Andy Brook, are you in the room? Yeah, okay. That problem we had earlier today, what was the problem related to? SDK? What OSGI problem did we have?
Exports.
Yeah, we didn't have our imports defined correctly. Yeah, 90% of these problems, quick fix on your imports. All right, so I've grandly launched into all this talk of OSGI bundles and plugins. What is a bundle? So an OSGI bundle is just a jar, a plain ordinary jar with 2 special entries in the manifest file. And the way we generate this jar is via amps. So it's the tool we've used way back to the dawn of plugins too, and amps is the tool that we should continue to use until the end of time.
And, you know, we have to put our hands up here and just say sorry, I suppose, at this point about amps. So many of you are probably frustrated, particularly if you're new to the ecosystem and you've started using amps for the first time. You're finding it's not exactly behaving how it says it should behave in the documentation. The tools like Fastdev no longer appear to work reliably. PI certainly doesn't work reliably. And the reason for that is the move to Java 8. Java 8 bytecode has really confused all of the underlying tools that run in there. And so all I can say is please bear with us. We know there's a lot of bugs in amps. We're releasing amps at a hell of a cadence. Many of you might be completely sort of annoyed about that. You know, there's an amps version comes out 2-3 times a day sometimes. And, you know, we've got a team now dedicated to try and make sure that it works consistently again. But we know it is broken at the moment, but it doesn't mean that we're not going to fix it. Amps will work again. I've got my fingers crossed. Amps will work again.
Yeah. Yeah. If you get stuck, please raise an issue on ecosystem.atlassian.net. We'd really love to help you. So if you do get really, really frustrated with amps, yes, it is possible to sidestep it and attempt to hand cut your own plugin. So yes, you could manually create your manifest, but I think you will be driven to insanity before you get there as you try and unravel the spider webs of dependencies that the tooling provided by amps can actually do for you. Yeah,
because, you know, if you hand cut your own, you have to really get in there, sort of control the Spring context yourself, understand that how Apache Gemini Blueprint is going to work. It's all quite, you know, it's not horrendously difficult, but it's boilerplate stuff that's in your face that you don't really want to know about. So the Spring Scanner is the tool that we use to try and hide some of that boilerplate complexity from us. Okay? Using simple annotations, component import, we specify what we'd like to make available, and we allow that Spring Scanner to generate the manifest for us. Okay? It's not perfect. It sometimes has bugs, but all code has bugs. But the vast majority of Atlassian's internal plugins now use the Spring Scanner. It stood the test of time. It is a tool that generates decent manifests for you, and takes away the pain of runtime transformation for you. So what is transformation?
Yeah, so last year we got quite a few questions from the ecosystem at large saying, what's this transformation thing? What's this Spring Scanner thing about? So I thought I'd try and explain what transformation is before we talk about how we can deal with it better. Transformation is the act of taking a jar containing your code, as well as your resources, whatever else you put in there. We then convert that jar into an OSGI bundle. Then we further convert into an Atlassian plugin. So we add the secret sauce to the manifest for both of those things to happen.
Of course, the secret sauce, and I've seen it in lots of plugins, and I've seen it in internal plugins as well. We go off, we make this, we set these rules up, and we try and load our plugin, and it doesn't work. And very often what we then do is just sort of say, okay, use import star optional. That suddenly makes it work. Okay? And really, please don't do it. Okay?
Every time someone uses star optional, I shed a tear.
Actually, that's a good reason to do it. Make Alex cry.
It's my clicker now, mate. Right.
So runtime transformation is what the products have done it for years. I mean, ever since we put the plugin framework 2 in place, the container boots up, it scans installed plugins folder, any plugin it finds in there, it runtime transforms it, and it says, okay, I've got to go and work out the Spring context for that. And that seems sensible. But you really run into problems. And those problems are due to the fact that it's a plugin system. So when you test your plugin, you may well have, 40 plugins in the system. When somebody goes and loads your plugin up, they may well have a completely different set of plugins. They might have hundreds of plugins you've never even seen before. And the plugin system makes no rigid guarantees about the order in which it loads plugins. Transitive dependencies are always searched. So if you've suddenly injected a dependency from, if you're relying on Commons Lang, for instance, and somebody else has managed to inject a different Commons Lang version in, then you get a class not found exception at runtime.
Hang on, James. Sorry, what are you saying exactly here? I could take one plugin jar and install it into 2 different Jiras and get something different at the end of...
Absolutely. Never mind 2 different Jiras. You can have your jar, and you could install it today and have it runtime transformed, and tomorrow you could have it runtime transformed, and the 2 jars that it produces are different because of different dependencies or ordering.
Oh, screw that. I don't want to do that.
No.
Is there an alternative?
Of course there is. I don't know who the picture's of. So build time transformation is what we really encourage you all to do. The beauty of build time transformation is you're building the jar at build time. It's not going to change. It's guaranteed to be the same jar. It's, as long as Maven works, it's guaranteed to be the same jar.
Maven always works.
Yeah. So the problem, of course, is that build time transformation has traditionally been hard. It's quite hard to go through all of your dependencies and figure out what you need. So we typically haven't done it in the past. But with Spring Scanner, that is much easier to do. Okay? So Alex will tell you a little bit about Spring Scanner, and later on we'll show you Spring Scanner. We're not going to show you in action here, but if you come downstairs, you can see it all in its glory.
So yeah, yes, we're asking you to do a little bit of work, but I promise the pain it saves you will be much greater in the future. So what we created was the Atlassian Spring Scanner. And so it allows us to put Java annotations into our code, and at compile time, we're able to determine what should be mapped to a component coming from a different plugin, what should be exposed to other plugins. Rather than doing that, making that decision at runtime when we first load, we get that decision baked in at build time.
Yep.
Now, there's a little bit of confusion around the Spring Scanner versioning. There's version 1 and version 2. Now these are functionally identical, and you can use either, and at Atlassian we do have a mix of both. The point being that the only difference is in packaging. So Spring Scanner 2 is actually packaged and provided by the products, whereas Spring Scanner 1 has to be provided by your own bundle. So if you want super awesome backward compatibility back to Jira 1.0, use Scanner 1. Otherwise, you're free to use latest and greatest Scanner 2.
So look, to be honest, that's what we're trying to get across here as a message. Please use Spring Scanner, go for Buildtime transformation. It's going to help your support load, I promise you, because your plugin loading is predictable. Of course, one of the other stories we keep hearing as plugin developers, there's a pain point. And the pain point of developing plugins is seeing the code change that you've done make it into your container.
No,
okay?
that's always worked for me. So I make a code change, and then I start up Jira with that code change in it. Surely that's a good dev loop, right?
Yeah, it's a wonderful deal. Sort of 10 minutes for every code change. So Quick Reload is a replacement for a suite of tools which many of you know and love, but which really are buried and dead. Okay, so Fastdev, Atlas CLI, PI, these mechanisms work, but they work unreliably. And we have tried. I mean, we've put hundreds of hours into trying to fix the bugs in PI and CLI to make them work with Java 8.
James has about 10% more grey hairs after that attempt.
And so, you know, it will probably always be in the toolkit because, you know, after all, until we no longer support Jira 6 and Confluence 5.10, you know, that's our mechanism for working. But in Jira 7 and Confluence 5.10 plus, Fastdev and PI are completely unreliable. In fact, there is almost no chance that PI will transform your plugin into a plugin that even remotely looks like the plugin that gets done during runtime transformation. And it's the same version of the byte scanning plugin. Everything is the same. We're at the point where it's just, so we rewrote a tool which doesn't rely on the complexity of packaging or doing any of that. It simply sits in the container as a plugin. You simply load this Quick Reload plugin. It watches the file system. Whenever you compile your code, and you sort of say Maven package, you've got a new jar. It says, thank you very much, I'm going to reload that jar. It's quick, it's simple, it works. Okay, and you know, Quick Reload. That's my. Please just use it. You know, it's on Atlassian Labs. You can get hold of it anytime you like. You can submit pull requests for features you want in there, or you can submit bugs. Either way, it's actively worked on. I was committing some source code to it this morning at 2 o'clock, so it definitely works.
So one more thing to note about Quick Reload is that the name is not a lie. So Fastdev was never fast. It would go through amazing histrionics to get the plugin up into your product. Quick Reload, it's really quick this time.
Yeah.
James, do I have to use amps, start my product with amps to be able to use Quick Reload?
No, you don't. I mean, that's the beauty of it. You can simply say, use Quick Reload true in your POM, and then amps will make sure that that plugin is available for you. But it's just a plugin. So you can use UPM, you can put the plugin in yourself, you can do whatever you like. It's simply a plugin. It relies on nothing esoteric at all. You don't need amps to do this.
All right, the dev and test loop is yours. You can put those magic instructions into amps, or you can construct your own containers. Of
course, we all know that despite all of that, it goes wrong from time to time. Okay, And so we've done quite a bit of work in trying to improve the diagnostics tools that are available to you. I mean, you've got some core diagnostic tools that come through with AMPS. You've got the OSGI module viewer, and you've got the OSGI tab on UPM.
That's pretty boring.
It is.
It's too dry.
So we present to you the plugin Visualiser.
So this was an Innovation Week project, which tried to come up with an informative way to show you what OSGI wiring is happening inside the entirety of the product. So you can, it's got a lot of filtering, sorting capabilities. You can even press Command F to find your plugin and highlight it.
Of course, you need to press Command F because you can't see the, that is a running Jira. That's the 206 plugins that typically exist in our
James,
cloud version.
That's not a running Jira. That is a beautiful work of art.
Yes. So download the plugin Visualiser. There's the link for it, and if you want to, you can make sure that it's available all the time in AMPS as well. You can just say Enable Plugin Viewer, and it's loaded for you by AMPS. Okay. Alex has been busy as well during his sort of innovation weeks, and he's created a suite of tools called MF Tools, and because you've got View MF, I mean, who needs anything else? View MF is beautiful.
So this tool suite is something that me and my team cannot live without, and we find it nearly impossible to diagnose. So we thought we'd better share it with you guys as well, because otherwise it's a bit like flying blind. So MF Tools allows you to, it's a manifest parser against a compiled jar, and it's a quick way for you to investigate the contents of a jar. So View MF views the manifest. You can dump it out as JSON if you're somebody who likes using JQ for complex Unix command line pipes. You can simply cat the raw manifest if you want to do some manual manipulation, or you can do a diff on the manifest between two jars.
Diff MF is the coolest tool out there. So very often, your plugin suddenly stops working. It was working yesterday, it's not working today. You know it's a manifest problem, but you just can't see what the difference is. Diff MF, great little tool. Just diff the jars and away you go. You see the differences.
And if it follows the Alex 90% rule that it's a problem with your imports.
So once again, it's available on Bitbucket. Go download it, have a play with it. Give us feedback, raise issues if you find bugs in it, feature requests.
I always accept pull requests.
Okay. So pretty much that's it. We haven't come up here, we haven't shown you any code or anything like that because we want you all to come downstairs to the breakout room and we'll demonstrate all these tools in the glory. We'll sort of show you them working in live time. So we've got 3 breakout sessions straight after this, but before I talk about the breakout sessions, we've said that we've had problems with AMPS. We acknowledge there's problems with AMPS. We're trying to fix those problems with AMPS. We're trying to fix problems with our developer documentation. We know that it's difficult for new developers coming to the ecosystem now because really the tutorials we have don't really work too well anymore. And so we've got a new team formed that's going to look after that. And Melissa Paisley is going to head that up and look after you also. Melissa's in the front here, so wave at you. So that team is ramping up now, and hopefully you'll start to see a difference in the developer documentation and tooling that's going to make your life easier. Because we don't want to make your life hard. We really don't. But the introduction of Java 8 into our products has really broken AMPS. There's no getting away from that. Okay. So the other thing is, I know that many of you just come along here for the cuddly toy.
What's
You're
his
not
name?
having it. It's mine. No, the cuddly toys will be given out at the breakout session. So we'll keep the cuddly toys. 3 breakout sessions straight after this. Whoops. 3 breakout sessions straight after this. I'm going to be talking about how to test for data center. How you get your plugins up and running in data center. Alex?
I'm going to be showing you how to use Spring Scanner to actually transform a plugin from Runtime to Buildtime.
And then we'll finish the day off by looking at quick reload and some of the dev tools that help your dev speed. So thank you very much for coming along here. There we go.
Woo. You know? So this is actually a world first. We finished talking rather than James blathering on for too long. Are there any questions from the audience? We've got a couple of minutes.
If you have a question, wait till I get to you with a mic.
Do you have any plans for introducing application-specific annotations? So, for instance, defining a macro within the code?
So that's a very good question. We have resisted, we've resisted so far introducing application-specific annotations. I'm not 100% sure we can resist that call for very much longer. There are differences between the applications that we need to take into account. So we probably will.
We do have some basic capabilities in there. So you can say, hey, I want to only load this component, say if I'm running in the Jira application, and I want to use this version of the component for Confluence because I know they behave differently. But that's about as fine-grained as it gets.
Yeah. Okay. Any other questions?